Today we will discuss an important chapter which is area related to circles. Before going to it, we have to discuss some concepts. That means degree, first one is degree to radians. How you will convert theta from degrees to radians? You have to remember 180 degree is equal to pi radian. If 180 degree is equal to pi radian, then theta degree will be equal to 180 by pi by 180 into theta radian. Theta degree is equal to pi by 180 into theta radian. Suppose you are taking 90 degree, then it will be equal to pi by 180 into 90 radian. That is equal to pi by 2 radian. This conversion we have to remember. Next is concept of arc. What is arc? Arc is the part of the circumference. This is a continuous portion of a circle. The part of the circumference is called the arc. It extends some angle at the center. Suppose here it extends angle theta at the center. If it extends a theta and theta is less than 180 degree, then the corresponding arc is called minor arc. If theta is more than 180 degree, the corresponding arc is called the major arc. Now, if we travel 360 degree along a circle, then it will cover a distance of 2 pi r. If you 360 degree if you will travel, and if r is the radius, then corresponding distance will be equal to 2 pi r. And if you travel theta distance, suppose from here to here theta we travel theta angle, theta degree, then the distance will be 2 pi r divided by 360 into theta. That is this one. This one is the length of the arc. And here theta is in degrees. You have to be cautious. Here the theta in degrees. Whereas if you express it in radian, then we will write if you travel 2 pi distance, 2 pi angle, if you travel 2 pi angle, then the corresponding length will be equal to 2 pi r. 2 pi radian, then the corresponding length will be 2 pi r, where r is the radius. If we travel theta angle, theta radian, then it will be equal to 2 pi r by 2 pi into theta. That is equal to r into theta, which is this one, where theta is expressed in radian. So L is equal to r into theta. Now, another concept you have to remember, segment. What is segment? It is the area formed by the chord and its corresponding arc. If we will draw a chord, we will have two arcs. One is the minor arc and another is major arc. The area between the chord and the minor arc is called minor segment. The area between the chord and the major arc is called major segment. Next is sector. What is sector? Sector is the area bounded by two radii and the arc between them. There will be two arcs between two radii. If you will see, two radii are here. One radii is this one, OA. Two radii. Another radius is OA. One radius is OA and another radius is OB. And between them there is if you will see, there is AB is the arc and another arc is here, AB also. This is the major arc. Now the area between the radii and the minor arc is called minor sector, whereas the area between two radii and the corresponding arc, the major arc, is called major sector. Okay. Now area of the circle, we know that it is pi r square. If we will cover theta degree over here, then pi r square by 360 degree into theta. That is equal to, we know that pi 360 degree is equal to 2 pi. If pi cancel out, then it is equal to half r square into theta. Or if we will put theta is equal to L by r, if we will put here, then we will get half LR, that is equal to half L square by theta. You have to remember this formula, that is only main important formula is half LR. You remember, and all other formulas you can derive. Area of the sector, you remember it is a half L into R, where L is the arc length and R is the radius. Next we will do some problems. First problem, you see, the diameter of a wheel is 63 centimeter. That means D is given as 63 centimeter. The distance traveled by the wheel in 100 revolution. Actually, in one revolution, it will travel a distance of pi into D. Pi is equal to 22 by 7 into D is 63. That is 22 into 9 centimeter it will travel. And again, for 100 revolution, if it will travel 100 revolution, then it will be equal 22 into 9 into 100 centimeter, which will be 198 into 100 centimeter, or that is same as 198 meter. The correct option is 198 meter B. Second question, if a sector of a circle has an area of 40 pi square units, that means area of the sector area is given as 40 pi square units, and a central angle of 72 degree. That means theta is equal to 72 degree. We have to make it in radian. That means 72 by 180 into pi radian. That is equal to, this is, if you divide it by 36, it will equal to 2, it will be equal to 5, that is 2 pi by 5 radian. Then area, we know that area of the circle area is equal to half LR, or that is half L is equal to R theta, or that is R square theta. That is equal to half into R square into theta is 2 pi by 5, and it is given as 40 pi. Here you see this pi will be cancelled out, 2 will be cancelled out, or R square is equal to 200, or R is equal to square root of 200 units, or that is equal to 10 into root 2 units. Hence option D is correct. Next question is, in the given figure, ABCD is a rectangle. ABCD is a rectangle of dimension this and this. So area, what is the area of the rectangle? Then area of the rectangle is equal to 21 into 14 centimeter square. And a semicircle is drawn. Semicircle is drawn with AB as BC as diameter. That means BC's diameter means diameter is equal to 14, or this implies radius will be equal to 14 by 2 centimeter, that is equal to 7 centimeter. If R is equal to 7 centimeter, then the area of this semicircle will be equal to half, let it be A1. A1 is equal to half into pi R square, it is half into 22 by 7 into 7 into 7, because R is equal to 7. Now is cancelled out, this is 11, 7 will be cancelled out, that is equal to 77 centimeter square. Now the shaded area will be equal to shaded area 21 into 14, that is equal to 294 minus 77, which will be equal to, actually what you can do it better in this way, 11 into 7 like this, and 8 1 217 centimeter. Given that R is equal to 7 centimeter, that is equal to OA is equal to OB. Find the area of the shaded region. If AOB is equal to 90 degree, this is 90 degree, matlab the length of the minor arc AB. Okay, minor arc, length of the minor arc is L is equal to R into theta. First you express theta in radian. Theta is equal to 90 degree, is same as 90 by 180 into pi radian, which is equal to pi by 2 radian. and L is equal to R into theta. R is 7 into pi by 2, that is equal to 7 by 2 pi. This is the length of the arc, and if we put the value of pi, 7 by 2 into 22 by 7, that is equal to this. You cancel out to 7 7 2, that is 11, so that is equal to 11 centimeter. This is the length of the minor arc. This is 11 centimeter. AB length is equal to 11 centimeter. Now area of the shaded region. First we have to find out the area of the sector. A1 let is the area of the sector. A1 area of sector. Area of the sector, which will be equal to, area of the sector is equal to half L into R. Half is there. L is 11 into R. R is the radius of the circle, which is equal to 7. 77 by 2. Now from this we have to subtract the area of the, this is the area of the sector, and we have to subtract the area of this triangle AOB. Then the area of the triangle AOB is A2. A2 is the area of the triangle. Area of triangle, which is equal to half base into height, half into 7 into 7, that is equal to 49 by 2. Hence to shaded area will be equal to, shaded area will be equal to A1 minus A2, which is equal to 77 by 2 minus 49 by 2, which is equal to 8 to 24, 28 by 2, that is equal to 14 centimeter square. This is centimeter square. Okay, shared area is 14 centimeter square. This is 14 centimeter square, the area of the shaded region. And this is the last question we will discuss. You see, find out the area of the shaded region. Let A1 is the area of the semicircle, area of the semicircle SCB, semicircle. This semicircle is this one. Let this one is the area of the semicircle. Now we will get this as, this is equal to, AB is equal to 13, it is given. AB is equal to 13, and next is AC is equal to 12. Now BC will be equal to 13 square minus 12 square root, which is equal to 5. BC is joined. Find the area of the shaded region, and if we will take here, radius is AB is equal to 13, means radius is equal to 13 by 2. R is equal to 13 by 2. Area A1, area of the semicircle, is equal to pi r square by 2, that is equal to half into pi is 22 by 7, directly write, into r square. Half pi into r square, 13 by 2 square, 13 into 13 divided by 4, it is 11, that is equal to 11 into 13 by 7 into 4. This is A1, area of the semicircle. Now area of the triangle A2, area of the triangle is equal to half base into height. This is actually 90 degree. You have to use the concept here. The diameter of the circle extends an angle 90 degree at any point on the circle. Suppose you are doing like this, anything, this angle will be also equal to 90 degree. Suppose that means the diameter subtends an angle 90 degree at any point on the circle. This is 90 degree, all are 90 degrees. Okay. Now if you will see, this angle is 90 degree, so that is half base into height. Half into base is your 5 and AC is 12, which is equal to 30, that is 30 centimeter square. So now area of the shaded region, shaded area will be equal to shaded area will be equal to 11 into 13 into 13 by 28 minus 30, that will be equal to, we have to calculate, if you will calculate, it will be equal to 13 multiplied 169 multiplied by 11, it is 1859 divided by 28, that is equal to 66.4 minus 30, that will come around 36.4 centimeter square. This is the area of the shaded region. Okay, and we will discuss other problems in next videos. If you find it okay, you can subscribe it. Thank you.